So this section is about determining limits from some algebraic properties of limits. So I want you to be able to determine limits using some limit theorems today. The first theorem is the one-sided limit theorem. And what that one-sided limit theorem says is that the limit as x approaches a of some function is only going to exist and equal L if the limit as x approaches a from the negative direction or from the left exists and is equal to L, and if the limit as x approaches a from the positive direction exists and is equal to L. Those two limits have to match in order for the limit as x approaches a to exist. So that's the one-sided limit theorem. The next theorem is a bunch of limit properties, and I feel like this whole theorem should just be called good news because this theorem says limits do what you expect them to do. If the limit as x approaches a of f of x is L, the limit as x approaches a of g of x is M. The sum rule says if I add those two functions together, then their limit would be L plus M. The difference rule says if I subtract them, I can just subtract the limits. I can even multiply these two functions together and take the limit, and that would be the same as just multiplying the two original limits together. If I take a constant times a function, then I can just multiply the limit times that constant. And I can also divide functions as long as I'm not dividing by 0. So as long as m is not 0, that quotient rule will work. And then I can also raise an exponent to a power and raise the limit to a power to get the answer. So I feel like the whole summary of properties of limits is limits do what you want them to do. What you expect, that's what they do. That's the good news about properties of limits. I have two examples of these types of problems. One example, I have a function that's just defined as a polynomial equation. And then I also have g, which is defined graphically. And I want to know the limit as x approaches 1 of f plus g. So according to that first the sum rule, I can separate this into two separate limits. So I could take the limit as x approaches 1 of f of x, and I can take the limit as x approaches 1 of g of x. Just doing two separate limits. And then I can add the result together. So if I look at f is a polynomial function, but I hope you agree, I'm going to change to red, sorry. I hope you agree that the limit as x approaches 1 of x would be 1. My y coordinate is going to get closer and closer to 1 as my x coordinate gets close to 1 if my function is just x. So f is really a bunch of those limit properties applied. I square x, I multiply by the constant 2, I subtract, and I multiply by the constant 3. So really I can just substitute 1 into that function to get my limit. So the limit as x approaches 1 of f of x is going to be 2 times 1 squared minus 3 times 1, which is negative 1. And I can look at the limit as x approaches 1 of g of x, and that's using that first property of limits. As x approaches 1 from the positive direction, or from the right, the y coordinate is getting close to 2. As x approaches 1 from the negative direction, or from the left, the y coordinate is getting close to 2. So that means since those two limits match, that limit as x approaches 1 of g is 2. I want to point out that there's a hole at 1, 2. Doesn't matter because, again, limits are just about if I'm close to 1, what y-coordinate am I close to? So by the sum property, that means that my limit of the sum would be 1, which is negative 1 plus 2. For example 2, I just told you a bunch of limits, and then I'm asking you to apply these properties. I'm going to encourage you to pause here and see if you can answer these questions, and then come back after you've tried the problems. So go ahead and pause and try this example, and then come back. All right, so number 1 is a quotient. I'm relieved to see that I won't be dividing by 0 because the limit as x approaches 3 of g is not 0. I'm going to be very deliberate about the first problem, and then a little bit lazier with the other problems. So this first problem, if I apply the quotient property, I can separate it into 2 separate limits. I can do the limit as x approaches 3 of f of x. I can then divide by the limit as x approaches 3 of g of x. I know these 2 limits because I told you them. They're 1 and 10, so I can divide the 2 limits and get my answer. That's the quotient rule. I'm going to be a little less thorough with number 2. Number 2 is a product. It's a product of 3 things, but you can just multiply them 2 at a time, and then, or you can multiply the first 2 together and then multiply by the third. So multiplying those 3 things together, I get 1 times 10 times negative 7, and so I get negative 70 for my limit. Number 3 is the power rule, so I can take the limit as x approaches 3 of g and raise that to the 4th power. So I get 10,000 for that new limit. And then number 4 is a combination of the constant multiple rule and the difference rule. So I have 5 times 1 minus 10, or negative 5 for the limit. Okay, these are the limit properties that you need to know. Good luck.